Greetings, ladies and gentlemen. I am Li4Ti5O12, the representative of our team, and I would like to present our findings. The title of our research is Synthesis of Lithium Titanium Oxide through Solder Method and Effect of Graphene Addition in Lithium-Ion Battery Anodes. The background of our research. As we have known, graphite has been extensively used as lithium-ion anode material. However, it cannot be used for electric vehicle due to its tendency to form SEI. LTO is a stable material to replace graphite, but its low capacity and conductivity needs to be improved first by either doping or modifying its morphology so that LTO can finally be used for electric vehicle applications. The advantages, as have been mentioned before, the advantages of using LTO for lithium-ion anodes are its zero strain property, its great life cycle and thermal stability. However, it has drawbacks such as its conductivity and capacity. Now, graphene as additives. Graphene, with its superb conductivity, can be added to improve performance according to various references. As for our method of fabrication, our team developed the solder method to produce LTO, and then we added graphene by using a facial magnetic steering method. This has never been done before for LTO. And then we proceeded by making coin cells. This is the materials and tools used to fabricate the materials, the LTO. And here's our documentation. First, we weighted the precursors, titanium oxide and lithium carbonate. Then we mixed them with aqueous and nitric acid. Then we added citric acid and mixed them for a while. Then we heated them at an oven and the results. And after that, we put them in a furnace at 250 degrees Celsius for 6 hours. And after that, the result was then ball milled at 900 RPM for 10 minutes. And then we put them in a furnace again for 5 hours at 500 degrees Celsius, and then the results. And after that, the mixing of LTO and graphene. I guess this needs to be elaborated further because it has never been done before anywhere else. And we are trying to utilize a process that has been tried on other materials beside LTO. First, we use sonication with the help of NMC. Then we heated graphene as a prototype. It is done to determine later just how much weight we're going to need later. Then the heated graphene is then weighted to determine the weight percentage of graphene. After that, we mix our LTO with graphene and then we stir them. We put them in an oven at 80 degrees Celsius for 6 hours. And after that, we assembled our products, our samples. The processes are weighting, mixing, coating, drying, rolling, slitting, opening, assembling, filling, and after that, crimping. And after that, we finally gotten our coin cell. As for the characterizations, we use SEM, XRD, Raman, EIS, CV, and CD. Now, here's our LTO products. Here's our independent variable. Our variable is the percentage of lithium addition. So let's say that we add plus 35% weight of lithium 40 and 55 show that the evaporated lithium may not decrease the result we want. And after that, here's the XRD spectrum. By seeing this, we can see that it still contains rutile and anodes. And as we see that LTO with the most Li percentage has the best purity. Here's the table to make it clearer. As we see that LTO3 with the most added lithium has the best purity. And now our SEM results. Our LTO has a quick grain with 0.58 particle size by using ImageJ software. And as we can see, our LTO size is normally distributed. Now, here's our SEM results of LTO plus graphene. As we can see, the graphene has not been distributed well enough by our process, which shows that our process still needs some optimizations. We can see further from our Raman spectra that our graphene has not been exfoliated enough, which shows that our graphene has not been made single, double, or triple layered. This obviously will affect the performance. Now, our EIS results. It has been shown that the conductivity of the sample with graphene is lower than without graphene. It shows that there's still some improvements needed. And here's the further elaboration as we see from the charge transfer conductivity. And here we can see that both samples have excellent P, which means that our samples' thermodynamic reactions are excellent. And here's the last one, the last characterization, which is CD. It has been proven again that without graphene, our sample has better capacity. Next, the conclusion. Lithium titanium oxide has been successfully synthesized through Soja method with variation of lithium addition of 35, 40, and 55 weight%. LTO with 55 weight% of addition shows 97.7% purity of LTO phase. The sample was then added with 5 weight% of graphene, and then their electrochemical performances were compared to LTO without graphene addition. LTO without graphene resulted in 140 mAh per G specific capacity, while LTO with graphene addition shows specific capacity of 85 mAh per G. Graphene has not been exfoliated enough and well distributed enough through the facile stirring method that has not been done before, which shows that the process still needs some improvements. As for our future works, we know that it is necessary to study the effect of graphene agglomeration during the magnetic stirring method and heat treatment process. Discovering ways to prevent agglomeration during the process also needs to be studied. Then here's the references. And we thank you all for having seen this presentation. And do you have any questions? Thank you.